this video, we're going to do some examples of verifying the solution for a given differential equation. I'm going to start with this problem here. And the given solution, y equals e to the negative x over 2, is going to be one that we're going to verify. We're going to find all appropriate derivatives for this solution. It's going to be negative 1/2 e to the negative x over 2. And then we're going to make those substitutions. 2 times negative 1/2 e to the negative x over 2 plus e to the negative x over 2. And we're going to verify, is that equal to 0? 2 times negative 1/2 is negative 1. Zero is equal to 0. So yes, this is a solution here. Next one's a little bit more complicated because we have a more complicated solution to check. Give myself a little bit of space here. So we have a second derivative involved in this differential equation. In our original or given solution here is that. So we're going to need to find the first derivative and the second derivative of that using our product rule. So that's y prime, y double prime. We're going to have 9 e to the 3x cosine of 2x minus 6 e to the 3x sine 2x. We have minus 6 e to the 3x sine 2x and negative 4e to the 3x cosine 2x. Add those pieces together. Get 5e to the 3x cosine of 2x and a negative 12e to the 3x sine 2x. That's just for our second derivative. So let's come in now here, and we need our second derivative. Minus 6 times our first derivative. Plus 13 times our original. We need to know is that equal to 0. And pull this down. So let's look at the fact that we have some e to the 3x cosine of 2x terms, and we have some e to the 3x sine of 2x terms. So we have 5 for the cosines there, minus 18 for the cosines there when we take negative 6 times positive 3, and we have 13 there. And then we have negative 12. And then negative 6 times negative 2 is a positive 12, and we have no sine terms here. 5 plus 13 is 18. 18 minus 18 is going to be 0. Plus negative 12 plus 12 is going to be 0. 0 is definitely equal to 0. So we have verified that solution as well. Let me look for one additional example here. And that would be something along the lines of this. Where it's not just equal to 0. So when we take the derivative here, let's go ahead and say y prime is going to be a negative x squared to the negative second times a negative 2x. So that makes y prime equal to a negative 2x is going to be a positive 2x in my numerator. 4 minus x squared in my denominator. So that's my left-hand side of the equation. And is that equal to 2x times 1 over 4 minus x squared squared. So 2x, 4 minus x squared squared. So that equal to 2x times 1 squared is 1. 4 minus x squared squared. 2x times that. And we would want to note with this that this would work as long as x is not negative 2 or 2, which would violate the domain of the solution there. So we would be looking at a possible interval for our solution set of negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. So those are our largest intervals of definition for the solution. And you might be asked to define that area in which your solution might be feasible. Okay, that'll be it for this video. We will come back next time and we will look at some similar examples, but we're going to have some constants of integration in them. So they'll be a little bit more complicated in verifying the solution because they're going to have a generic constant in them. I'll show you what to do with that. So see you for the next video.